We'll get it going then. All right. My name is Adam Penna, and I'm here to continue the conversation in 3D printing and additive manufacturing. Happy to have today another guest coming from Meltio, which is a company that is now doing large scale and normal 3D printing in metal, but they're actually taking it to a different level. They have a lot of interesting things going on. So I was talking with the Yashwanth Bandari here. He goes by Yash. Yash, welcome today.
Thank you very much. Thank you very much for having me, Adam. I'm quite excited for this. Well, perhaps I should say that I'm on cloud nine.
Yeah.
I've always wanted to, talk to you, share my views, exchange our views on 3D printing. I've been doing good stuff on 3D printing, and we are, meeting at the right time in the, in the new normal. So I appreciate you taking your time and interviewing me. Thanks.
No, I appreciate you having the conversation. I know we talked a few weeks ago about things, and there's so much happening. We had even an intersection of different people we've worked with in the past. We could mention that a little bit later if we want, but I wanted to focus on what you've been doing, because you actually have just been coming to the company, but you have a great big background. I know that you've worked in National Laboratory. You were also working at doing work over there, and then also coming in with you have your PhD. You worked in this industry doing a lot of thermodynamics and temperatures and dealing with what happens inside of wire 3D printing and the materials there. I was looking into the background. I was very intrigued because you've obviously been doing a lot of things to bring a lot more background to the game now, and joining Meltio, that's very exciting. How has that been for you over the last year or so? I know this has been interesting for all of us, but starting with a new company during this time must be very interesting. How's that going?
Yes, I'll be honest with you. Let me just take back, since you mentioned a little bit about my background. Most of it is correct, but I just want to
Oak Ridge National
refine it.
Yeah. Sorry, I got that wrong. Yeah.
Refine it, actually. So aim in my life actually started like an accidental passion, actually.
Yeah.
But over the course of time, it became a real passion. So it all started in 2010 when I was doing my master's. At that point, it was a buzzword. Everybody was talking about 3D printing, additive manufacturing, and I thought, this process is, used to make cool toys, demo components, sort of, plastic or polymer. Then I went on to take a course, and I did my master's thesis on large-scale metal additive manufacturing. Yeah. And during that time, I had an opportunity, to give a talk at an international conference in Singapore. And guess what? I won the best paper award. It was totally unexpected.
Nice. Yeah.
And it was, so that's how I started my, research in metal 3D printing. And I went on to do a PhD at Cranfield University, UK. And it's one of the best schools for metal additive manufacture. And Cranfield didn't pay me to say this, but it's one of the facts, actually. So I took a big leap, and continue research doing at Oak Ridge National Lab. And then after attending several conferences and trade shows, I realized that basic science is not my cup of tea, actually. So I was more interested in taking this technology to the industry, help the industry adopt this technology. And EWI gave me a good platform to express myself in approaching and engaging with customers, and who always wanted to get into this large-scale metal stuff, but didn't know the know-how of this process. So I was instrumental in taking this technology to a wide range of customers, and I was quite successful. And then later I joined Meltio. Yes. So this is my second month, I would say. I'm already excited.
Wow. Yeah.
Thrilled with the the uniqueness of our technology, and receiving so much of enthusiasm and customer inquiries regarding our products, and what's the uniqueness that defines the large scale metal stuff that we are doing, actually.
Yeah.
So I mean, there's a constant inflow of projects that we are doing, but we're doing our best in this new normal to deliver projects, machines, customers on time. Well, about customers, you have done a lot of work with customer interactions and everything. They want everything to be delivered yesterday rather than today or tomorrow.
Sure.
So even with this new normal, we are still trying our best and yeah, getting things done on time.
Yeah, that's it's an interesting journey, and I know that it has been obviously, like you're talking about, a lot of your passion and what your direction has been, and now getting to this company and being able to share that and work on different things with project with customers. That's again what we all do. We're trying to figure out what works best for the customer. So where Meltio fits in, I know that they have their own metal printer that they sell, but you also integrate with other machines, right? With the technology, and you have the ability to use not only metal powders but wires, and you could do that together. Is that correct? Is that how the actual process can work? Can you describe that process a little bit? I haven't seen a machine myself, so I apologize for that, but I'm looking forward to seeing one live pretty soon, so we'll figure that out somehow.
Absolutely. Yeah, let me tell you a little bit about Meltio.
Mm-hmm.
Meltio is a little an year-old company. It's a joint venture between three great companies: Aditech, that's based in Las Vegas, where I'm based at, and Signova, that's based in Spain, and third company is ArcelorMittal. So Signova, so we have our headquarters in Spain. That's where we develop our products. We have a capability to produce more than 200 machines a month. I mean, 200 machines is a really game-changing number. If you talk about metal 3D printing companies, actually. And then Aditech here, we do a lot of R&D, and we do a lot of things on photonics. So we develop our own lasers, laser systems, laser heads, optics, and powder feeders. And then these three great companies came together in May 2019, and it was formally launched at Formnext 19, actually. I know it was disappointment this year. The Formnext is canceled.
Yeah.
It was a heartbreak for us, but we were like suspecting that, over the course of time.
Yeah.
So the thing which differentiates our technology with the other technologies is, so we can feed both wire and powder on a single laser head. So essentially, you are leveraging the advantages of both wire and powder. So this kind of process, you can't find it in books, because this is a relatively new process. We have been researching for about like 5 years, put a lot of effort in developing this technology, and then the products out of this technology. So in terms of products, as you mentioned rightly, we have two main products. One is a small compact printer, which I call it as M450 printer, where you can make small scale parts. Again, small as in, when you compare with powder bed parts, they are relatively large. But when you compare with wire-based additive techniques, they are small parts. And then the other product is our engine. So engine, as the name suggests, it's the heart of the process, or the energy source of the process, which comes with the laser head. I still have my laser.
Oh, nice. Cool.
So yeah. So these are our patented laser heads. So our engine, it can be retrofitted to any CNC machine, or to any robotic system. So again, this will be very useful if you want to print a large scale additive stuff, because on 450, you have a limited size, it's compact, reliable. Yeah, I mean, people ask me, and how reliable it is. I say, it's as reliable as the rains in the Seattle. So,
cool.
And then so we have good interest for M450, especially from research organizations. So it's just a feature of
how big is the bed in the 450? Is that 450 mils? Is that number match, or how big is the actual size of the bed?
Yes, so 450 as in the maximum height in the Z direction is 450 mil, but you can make parts as big as like 200 by 250 mil in the horizontal direction. But if you want to make large scale parts, we have our engine. Again, all the technology of engine is already there in M450, but engine has a lot more advanced capabilities, like higher laser power. Higher laser power will give you high deposition rates, and you can print large scale parts easily on these CNCs or robotic systems. So I think we are the first ones who developed this kind of technology, where you integrate both wire DED and also powder DED on a single machine, actually. So And then basically our main vision is to, make this process, as affordable as possible, and so that masses can use it. Because at the moment, most of these machines, in the market, they're very expensive. The
Sure.
basic versions start anywhere from 500K. So they're very expensive, and research organizations or even universities, they're taking a back step, and especially during this COVID times, we want to sell machines which are affordable, compact, and reliable at the same time.
Yeah, well, you brought up a lot of things there, but something that kind of stuck out to me as far as you were even showing the actual head there behind you on the table. So when you're actually using both a powder and through
wire, welding wire, conventional.
It's a wire. So the wire and the powder together, how is that fed? I know I could see the head there. So they're both going through at the same time, or?
So instead of me describing, I would like to show you.
Nice.
Yes, and then
great question, right?
It'll give you a good understanding. Actually, I talk to several customers a day, and they look at all this stuff, but you're the first person, who was intrigued, with the lasers and everything.
Sure.
So this is our first version of our laser. So we have our lasers coming from, so they're all off-axis lasers.
Yeah.
So in general, in most of the other processes where you have this coaxial laser, and then it comes right in the coaxially. Yeah. And in some other cases, where you can have one fiber diode and you do beam splitting,
right,
and then they converge at a focal point here. Okay, but we are not doing neither of them actually. So we are taking a different approach where we are using this fiber diode coupled lasers, and we are not doing any beam splitting, but they can be detachable. So each fiber laser has got its own power, and it can be controlled. And then, as you can see in the nozzle, so this is our patented laser head. This is one of the new old versions, and I've got the new version as well. So from here, from the central nozzle, you get this wire, and then you also have this powder nozzles, as you can see on this laser head. Sure. So you can use wire and powder both independently and also simultaneously.
Wow.
Actually.
Wow.
So there are many applications, where using both wire and powder makes sense actually. So like not too many people have explored this kind of technology before. So that's the reason, most of the universities, they are interested, and they say that, this is one of the kinds, where they have been looking forward, when you compare with other, commercial machines.
Well,
so yeah, there's a lot of possibilities.
Yeah, what makes sense to me when I'm thinking about that, and thank you for educating me on this a little bit. I'm starting to absorb a bit here, hopefully. But also when you're building a part, there's parts that don't have to be so accurate. It's just a thick wall or something like this. So to use maybe the powder for that isn't quite the application, and laying it down with the wire might be better at that time. You're saying you could actually switch between it. So I'm assuming that you become more precise when you go to the powder. Is that correct?
Yes.
It is?
So
okay.
Yes. So if you want to make like complex features or fine features, then you can go switch to powder. And then if you want to make thick walls, as you mentioned, where the accuracy is not that essential, then you can use wire. The advantage of wire is, it is because it's just a form, it is present, so you can, the biggest advantage is the cost. The cost of wire is, at least like 3 times lesser than the cost of powder. Mm-hmm. But at the same time, not all materials are available in the form of wire. So that's why it makes sense to, use, you can use, plug and play, wire and then switch to powder. Or if you want to use both at the same time, there are many applications where you can use both at the same time too. So it gives a lot of flexibility, and not just one wire, you can use, several wires at the same time as well.
Okay.
That gives you
multiple heads during the build,
exactly,
depending upon the setup.
And then you can make customized alloys, with this. So lot of possibilities. It's just we have to explore and get this thing, out with the public actually.
Yeah, that is really neat. So talk about expanding. I know you're talking about automation and sometimes robotics. You're saying multiple heads, obviously, so you could have multiple operations to grow apart. Is that what I'm saying? Like if I had multiple arms that were building something from different angles, is that possible with that? Is that something that's happening right now?
So right now it is not happening, but we are having a project with a nuclear company. So the end goal is to make a part as large as a human being, about like 6 to 7 feet,
Wow.
where we will be using different several multiple laser heads, so that you can speed up the build time, and get it more automated, use it on a robotic system. So the end goal is to use a robotic system inside a CNC system, so that that'll be a lot more flexible, in terms of sizes, and even in terms of cost, it'll be a lot more affordable.
Yeah, I mean, it's a little bit of the science fiction, but it's becoming true. I mean, I remember seeing Iron Man, obviously, and a lot of people, point to how quick he built the suit when he pressed the button, but it, kind of had those multiple build heads there, and it was all happening very quickly. I'm like, yeah, that's the movies. It's a lot slower than that, but yeah, that's kind of what's happening. Being able to build now, and now you're taking it into a robotic automation environment and being able to scale and do some things and really kind of come to a new way of building that. You could see it happening. It just takes the right technology and minds behind it to push it there. So that is really interesting. That's amazing.
Absolutely. So and then there's again a lot of element of science which is behind these technologies.
Yeah.
So yeah, it's just we can't just hook it up to any robot or any CNC and just let it do deposition. There's a lot of things behind that. How do you control the microstructure which will later affect the mechanical properties? How do you control the cooling rates? At the same time, how do you control even the geometry, so that, it replicates the same as, the CAD model. So,
Yeah.
And then how do you make everything automated? Even that is something, we are working, along with, I'm sure, different organizations are also working in this actually. So,
Yeah.
Yeah, it's great to be in this area, and then especially the way people are coming to know more about this, and really using this technology to build their products, and affecting their business cases.
Yeah, that it is. It's really neat to see that happen, and the people that kind of can gravitate towards the technology to bring it to that next level. Now, you mentioned a little bit about the materials, especially on the wire side. So, and I'm assuming obviously the steels are in there. Like, what other wires or materials are you working with on that side?
So basically, there is no something like you have to use just one particular material. So any welding wire that is available in the form of a wire in the market, it can be used actually.
Okay.
So in the same case applies with even for powder, anything available in the market, it can be used and fed in the process. So we have demonstrated parts out of steel. That's the first and foremost. And then titanium, we have a lot of interest from our customers, especially on titanium. It's just typical aerospace component, and then internal stainless steel. And recently we got we have demonstrated some parts using these exotic alloys, as well as some refractory alloys like tungsten, molybdenum as well.
Oh wow!
So
nice.
Yes, and not just as.
Yeah.
Not just this, because we're also building a couple of very small scale printers, which would do this kind of operation or similar kind of operation in the orbit or the ISS actually. So these are a couple of
Special
sensitive projects.
Sure.
That very much interested in seeing forward.
So, I mean, we talked a little bit about that too, as it come along, and we talked about robotics and automation. So what do you see as some of the bottlenecks out there that this is going to overcome, or you're pushing to overcome?
So especially, so even our process, it falls under DED processes. The bottlenecks for DED process is basically it's not yet completely automated. When you compare with powder bed fusion, processes, where they make small scale parts, It has been there for more than 25, 30 years, I would say, powder bed fusion process. But DED process, it's kind of relatively new, like 10, 15-year-old technologies. And people are still trying to find out, the right process parameters, to build the right components and out of the right materials. So this particular correlation, to know, what kind of process parameters needs to be used so as to attain good mechanical properties is something a bottleneck right now. Yeah, it's not like, you hook up any heat source to a robot and just printing the part. There's more an element of science behind this. So how do we make this more automated? And then there's a lot of research going on, especially on simulation. So this helps, in terms of, process qualification, and also in terms of, QC and QA actually. So, because we can't build every other product to see and test for the defects and evaluate properties, right? So, so this simulation will play a lot of role in automating the process actually. And then, this process could be used in all sectors, be it aerospace to automobile to oil and gas to space, and every sector has their own requirements, own specifications. But one good thing is aerospace, it jumped into this technology way ahead of other the sectors, and we are working in tandem with different aerospace giants, to make this more affordable at the same time, cut down the lead times, and make sure that this technology qualifies their particular requirements. For example, according to ASTM standards or ASM standards actually. So these are a couple of bottlenecks, I would say, and people are actively working on this. We are also working on this bottlenecks. How do we make this more automated? I want to see one day basically where a person who doesn't need to have a PhD and go there and just push a button and
that's the dream, right? That's it. I was just talking about that earlier, pressing that button and making it happen, but it's a lot more, isn't it?
This is advantage. This is the advantage of a DD process, where you can see the part growing up, just like a baby inside the stomach, you can actually see grow it, unlike powder bed fusion process where it is completely immersed.
Yeah, it's underneath the powder,
and you don't know what's going on unless, it comes it out actually. So we can't repair, during the process. So this is one of the salient features of DD process.
So with the DD process you have, then are you talking about actually having a closed loop system where you could see something happening and make adjustments on the fly? Is that what you're saying?
Yes.
Oh,
yes.
cool.
So we do have closed loop systems on our machines, but in general, it is very much important to have closed loop algorithms, closed loop softwares. Not just for DD, even for powder bed fusion process, so that you can repair on the go, and having this hybrid system gives us a lot more flexibility, because if something has gone wrong, for example, you can just use the milling cutter and then chop it off and start printing from there onwards. So this is something not possible in powder bed fusion processes, but only exclusively to hybrid manufacturing when you use a CNC machine.
Yeah, no, that's true. And so having the capability to do one or the other depending upon the application again, that's wonderful. Wow. So getting past the bottlenecks then, what do you see? We talked a little bit about what's happening. So the unique processes that you have, what do you see like where Meltio is going in the future?
So in the future, the Meltio's unique technology can be applied in pretty much in all sectors actually. So right now I can just give you an overview of our projects, just to emphasize on different sectors that we are we are working with actually. So most of the projects, they're based on aerospace and space applications. As I mentioned, we are working with a couple of space companies and building customized printers where they can do welding and repair applications in the orbit or in the ISS, and we're also working to develop a lunar lander where which also has our machine, which can do this repair applications. And not just that, we are also working with a couple of companies, who can do, excuse me, who can, generate these turbine blades, where you can repair the turbine blades. Yeah, because I just heard, like last week or so, that Optomec company has repaired more than 1 million blades. Actually, it's a big number, So the advantage of DED process using in the form of a repair application, it takes the costing completely out of control actually. And we are also working for some jewelry applications. So for printing watches.
Okay.
It's cool. It's cool. When I came to know about this. Where you can print watches, dials, and a couple of material, parts out of copper as well. And
okay, I was going to ask about that. You're getting into the copper side also. That's good.
Yes,
a big deal. Especially when you're getting to large scale metal AM. You've seen a lot of what's happening out there with the thrusters and combustion chambers that are being built with the internal cooling systems and all that. There's a lot of interesting things going on. So yeah, that's a whole process that you have to go through, and it's good to see you guys are at least pushing that forward. That's big fish game, I guess you could say. All the big fish are in there trying to figure out what they can do on the metal AM side that could help inside of aerospace, inside of propulsion, and doing things. So like you're talking about, the ISS is the International Space Station, for all the people who don't know all the acronyms out there, but it's happening right now. Those kind of things are the projects that are in development. So it's really exciting, it betters humanity. It betters what we can do with our space program and things that couldn't be done before, with especially heat. When you're talking about combustion chambers, you're talking about heat and the ability to build something that also has some different, like the copper and working with these materials and having the ability to do things inside of the walls of all of these combustion chambers. It's just amazing,
Yep. And at the same time, our one of the top priorities is, to achieve these things, what I mentioned before, at an affordable cost. Actually, you can do the same stuff, spending millions, but that's not the way we want to approach this game. We want to make this process as affordable as possible to the masses, so that they can use it for their applications. Probably this is one of the reasons why large scale additive stuff or DED process is not there in all sectors. I would say it's there in most of the sectors, but again, a couple of sectors like automobile sector, they are kind of reluctant to use this technology. One is like cost, one is again the qualification, and they're scared about what would be the mechanical properties kind of thing. And at the same time, other commercial machines are so expensive that it's hard to get the funding. That's what I heard from these general managers from automobile sector actually. So if you can make this more affordable and with less operational cost, I think people will be more readily accepting these paths, and at least giving it a try. If they can do compare the business model with the additive stuff compared to the traditional manufacturing.
Yeah, I know it's hard to say, and I guess if you're just comparing it against traditional manufacturing, there's a lot that you could look at there. But what is it that in particular, if you can say what Meltio is doing that is lowering that cost? Is it just the technology itself, the materials themselves? What actually lowers the cost for the consumer?
So basically, technology, yes, it is new, but all the welding wires and consumables, we just buy from the market like anybody else, actually. So the main thing which reduces the cost on our products is we develop our own lasers. So basically, most of the other companies, they buy, for example, Fraunhofer's or laser line, which are quite expensive in general. But in our case, we develop our own lasers, we design our own laser heads, we develop our own optics, and even our powder feeders. We have got all patents filed on these products.
Okay.
So this is how we are, reducing the cost of the overall product.
Yeah, no, that makes sense. That's interesting. Is there anything that you'd want to let us know about that we could see some more information about Meltio?
Sure. Yeah. I mean, yeah, during our conversation as well, I wish, we would have had more time, to,
Sure.
explain more about our Meltio's products, and then, the process, how it works. But yeah, people who are interested, learning about our technology, our products, yeah, I highly suggest them to, register for the webinar. And we do have, several webinars coming up. Yeah, we have been seeing more number of people registering over the course of time, and yeah, it's going to be a good experience. You'll be getting an opportunity to witness our machine, and then look at the process live. You look at the deposition process live. So it's going to be wonderful, actually. So please visit meltio3d.com website, and please register. To undergo a beautiful experience.
Yeah, no, I'll put a link to that, and of course in our talk here today, and people could reach out and check that out. I think it's important, obviously, to spread that message. A lot of good things happen at Meltio, so looking forward to see that come to fruition. Hey, Yash, it's been great to have you here. Is there anything else you want to talk about before you're gone?
Yeah. So on the other side, yeah, it's been like exciting, catching up with you. I've seen your most of your previous video podcasts.
Oh, cool. Thanks.
You've been doing a great job, I would say, in covering interesting people, interviewing people, and covering a wide range of topics. Covering the best in business, and there's always an element or two also to learn, from all these videos. And yeah, and yeah, a big high five, for doing this
Hey, I
amazing
appreciate
job,
it.
and let's
No,
be in
no.
touch.
Yeah, for sure, Yash. I mean, that's it. Thank you so much. It's just been an honor. There's a lot of great people and a lot of great things happening inside of 3D printing and additive manufacturing. So it's nice to hear these stories, very positive, and a good thing for also to focus on and to learn about. So I'm just glad we have great people like you to connect with. Thanks again, Yash. I appreciate you being here today.
Sure. And last thing, then, when
Yeah.
the travel restrictions, get relaxed, you are more than, welcome to visit our facility, spend some time, with our engineers. I'll give you a good, tour of our facility, and yeah, you'll be
Where's that
amazed.
facility located again? What city is it?
Yeah, it's in the Sin City, Las Vegas.
Okay. Oh, yeah,
Yeah.
no problem coming to visit over
So,
there.
so apart from casinos and
Yeah.
everything else, so there's a little bit of technology too. So, a couple of customers, who are just entering into additive manufacture, when they realize that we are using additive manufacturing as our technology, they ask us questions like, hey, do you print the casino tables? Do you
Oh
print
gosh. Yeah.
blackjack tables? So
Yeah. Sure.
these are a couple of questions I get to hear, actually. But yeah, we don't do polymer and plastic stuff, but more into metal stuff. Basically, you
Well,
can see on the aeroplanes and space. So it was nice to catch up with you, and thank you very much for your time.
yeah, definitely. Have a good one, man. We'll talk to you soon. Thanks again.
Thank you.